So I just did like a car detection. It's an intelligent transportation application, a people detection application. Yeah, so this is kind of like an agriculture application. Like you can count the apples and
Good morning, everyone, and welcome to OpenCV Weekly Webinar, episode 98, if you can believe that. I'm your co-host with the co-most, the second banana who is second to none. I'm also your plus one and only. It's Mr. Nelson. If you're nasty, but you can call me Phil. And I'm here to host this episode by myself because Dr. Satya Malik is not feeling well today. If you'd like to send get well wishes, please send them to newsletter@opencv.org. But I'm pleased as punch to have our guest here this week, Lakshantha Dissanayake, who will be talking about the new Jetson Orin product. Specifically, he's from Seed Studio. We'll be getting some benchmarks and apparently a live demo, which I'm really excited about. We love those brave live demos here. But before we get started, I'm here to remind you of a few things we do every single week on this show. The first of which is a giveaway to you in the audience. Stick around. Later in the episode, you'll get the chance. One lucky winner will answer a trivia question and get a $100 coupon toward a Jetson product in the Seed Studio shop. Thanks so much to Seed Studio for that. We're also taking questions from you in the audience, so use the little Zoom Q&A button at the bottom of the screen or ask your question in the chat system wherever you're watching, whether it's Facebook, Twitch, Twitter, whatever. We will do our best to answer every question that comes in, but we can't promise anything. That's about it from me for right now. Lakshantha, the show is yours. Tell the people who you are and take it away.
Yeah, thanks a lot, Phil. And I'm very excited to be part of the OpenCV Weekly webinar again. I actually joined this webinar 5 months ago with you together. And we were talking about the Jetson products, and the Orin was not released that time, but they just announced the Orin series. But now today I have the Orin hardware actually on hand with me so that I can show you all the exciting things that Orin can do. And thanks again for inviting me again on the show.
Mm-hmm. So thanks for joining us. Really looking forward to it.
Yeah. So today's webinar is about AGI, the meeting the server level performance, right? So mainly we will be able to see like how almost it can match the performance of a data center, right? So talking a little bit about myself. So I'm Lakshantha Dissanayake, and I'm an application engineer at Seed Studio. So actually, I'm mainly focusing on embedded systems, IoT, and AI. And also, recently, I'm mainly embedded in the Nvidia Jetson ecosystem, and I'm spending my time developing demos, writing documentations, and also the tutorials on how to get started with these products. So that's what I mainly focus at Seed Studio. And if you want to connect with me, you can check my LinkedIn.
Okay, let's roll.
So yeah, and also I have worked as a Udemy instructor in the past. So that's a little introduction about me. And yeah. So, and this is about the giveaway. As Phil mentioned, we will have a giveaway today. We'll be giving a $100 coupon, a store coupon, for the Nvidia Jetson products on our Seed Online Bazaar store. So stay tuned and stay until the end of this weekly webinar, and we will ask a question, and the person who answers the question at first will be able to win that coupon. And also, I want to tell you guys, like, just carefully follow along through the webinar. The question will be very specific. So yeah, just carefully, listen.
All of you that have been getting the answer way too quick lately, you're on notice. I didn't even come up with this one.
So yeah, so let's get started. So before we start, I will give a brief introduction about Seed Studio, because actually I introduced Seed Studio in our previous webinar as well. But maybe there are some of our new viewers who are not familiar with our what we do. So normally Seed Studio is an IoT hardware partner, and we started in 2008. And Seed has been the hardware partner for 470,000 plus global IoT developers. And we closely work with leading chipset companies. And we provide thousands of open source modules for rapid prototyping. and also help scale up projects with agile manufacturing services and also global distribution networks. And we recently announced the roadmap of an advanced perception system of modules and devices and solutions. So actually, we aim to bring system integrators a full toolkit of sensing, networking, and edge computing to leverage digital transformation for industries. So these new releases that we released during this last month, actually, we had an event on the Pi Day 314, and we announced all the products that we'll be releasing in 2023. So at the end of this webinar, I will attach a link to the product catalog that we released, so that you can have a look at all the products that we'll be releasing in this year. And we are planning to release really exciting products for 2023. So actually, focusing on embedded AI, we are the NVIDIA's elite partner, and we provide full product lines from imaging sensors, LiDARs, development kits, career boards, and full systems. As you can see in this slide. So we are also an approved design partner of Raspberry Pi. So what we try to do is we try to address custom solution needs through hardware customizations, right? We just not sell our products like out of the box. We also do customization services, and we also partner with ISVs, because we are the hardware provider, and we want to partner with the software providers, so that we can bring hardware software solutions together to the market, and also deliver all the AI applications together with the products that we manufacture. So this is a brief introduction about Seed Studio, and you can visit seed.cc to learn more about Seed Studio, and also visit seedstudio.com. So that is our online bazaar store to explore all the products that we offer. So let's get started with Edge AI. So because now actually, so we are talking about the Jetson Orin series in this webinar, in this weekly show. So I think it's better to have a little bit of like background about Edge AI. So actually, so as we all know, edge computing is a pretty famous term. So when we talk about edge computing, what edge computing means is we try to bring the computation and the data storage closer to the location of the device, right? So what Edge AI means? Edge AI means it's a combination of edge computing and artificial intelligence, so that the data generated will be at the hardware level. All the processing, all the AI inferencing and everything will be done at the edge. So that is Edge AI. So what we get from Edge AI is mainly we can get an improved data security and privacy, because this is something that many people are concerned about. So they don't want to send their data to the cloud if they want to do some inferencing on their data. So, and also for the cloud costs, because sometimes if you want to use the cloud for inferencing, there are some providers where you need to pay like subscription. They have subscription-based plans, so you can reduce all these costs as well when you're running at the edge, right? And finally, you can also have the reliable operation, because like if something goes wrong at the edge, you can just go out there and fix it by yourself. You don't need to rely on the people. Yeah, so as we can see, this is how it has evolved during the years, the NVIDIA, the Edge AI products in general. Yeah, as I was explaining before, so now the devices have gotten smaller, and actually you don't need to run big models on these devices, because now we have really optimized models which are able to run on smaller devices. So that is the power of the algorithms, right? Or software, the algorithms can really make a difference when it comes to optimizing the models on very small hardware. So why do we use Jetson? So why not the GPU? Because GPU, of course, you need a lot of space and it's very heavy. And the Jetson platform is very compact and it's edge ready. And also it's expensive, the dedicated GPU platform, and this one is very inexpensive compared to that one. And also when it comes to the power consumption, it consumes very low power compared with the GPU, the dedicated GPU platform. But there's a drawback, and that is the high computing capabilities which the dedicated GPU platform can offer compared with the Nvidia Jetson platform. But even though it can offer the high computing capabilities and run the heavy AI models, even though the Jetson platform cannot run heavy AI models, we can get very decent performance out of the hardware optimized models that I mentioned a few seconds ago that can be run at the edge. So we are not really compromising a lot. We are compromising a little bit, but at the same time, we can really like get out all these benefits out of running on the Jetson platform compared with this other dedicated GPU platform, right? So today I would like to show off our latest Jetson hardware I have with me. So that is the Recomputer J4012 right here with me. So I will stop sharing my screen for a bit. Okay. So this is the latest product that we have from Seed Studio, the Recomputer J4012, and it is powered by the Jetson Orin 16 GB module, right? Which offers 100 TOPS AI performance. And
that's a lot of power in a small. So that's about the size of like a Mac Mini, a little bit right. Taller on the Z stack, I would say. Yeah.
Yep. Yes, exactly. Cool. So we have this device. Actually, what we offer is, as I mentioned before, we provide full systems where we have a nice looking enclosure like this, which and the board is sitting inside this enclosure. So we have the I will where is it?
Nice bit of kit for sure. I'm interested in these myself for some of my little independent projects that maybe I need something running like a web server, like why should I be paying for co-location or web hosting when I can just spend like $40 or $80 and buy one of these little single board computers?
Yeah, for sure. So I'm gonna show. Let me remove this screw to take out the board from the enclosure. Give me like a couple of seconds.
You got any recommendations for electric drills?
Oh yeah, I'm using this. Yeah.
So, you like that one? What brand is it? We'll give them.
Actually, this is Xiaomi. It's a Chinese company. Maybe you've heard of Xiaomi.
I think I've seen them on for sale on Amazon, right?
Yeah. So I'm using this. To open to get out all the screws from here, and so we can just remove the board from this enclosure.
Cool.
And then once we remove it, so we have the device here, and so this is the Jetson Orin module itself with the heatsink on top of it, right? So this is the module, and this is the heatsink, which is there's like a thermal paste between the heatsink and the module.
What kind of decibels are we? What kind of decibels does that fan put out? Like, how quiet's the fan?
The fan is pretty quiet. Like, to be honest, like I have not really like tested with the decibel meter, right? But I can like confidently say that it's not putting out a lot of noise for sure. Yeah. So if you compare with the PC like fan spinning, I feel like this is not that of a high pitch as most of the fans that you can find on laptops. So
that's good.
Yeah. So basically it has this 260 pin sodium connector, and what we do, we have this carrier board. So this is what we manufacture, right? So because the Jetson Orin module comes from Nvidia themselves, that's what they manufacture. So what we do is we manufacture the carrier board, which is able to connect this Jetson Orin module to the board, and then we have all these IOs on the carrier board. So we have a USB 3.2, 4 USB 3.2 connectors, one Ethernet connector, and we have one HDMI, one barrel jack connector for power. So actually this is powered using 12 volt at 5 amps. So that's the specification of the power adapter which comes with this particular board. And it has got 2 CSI cameras right here, because normally like some people want to do some robotics projects with this kind of hardware. So so they don't want to connect USB cameras to this board because they want maybe a compact solution like this. So if they want like solution with no connectors over here, like on a robot, for example, they just use the internal CSI camera connectors, bring a camera out here from here, and connect the camera outside to do all the vision detection and all cool. The cool stuff.
Sounds pretty customizable then in terms of or versatile in terms of the solutions offered for integrators.
Yeah, for sure. And also it got the 40-pin GPIO. It's a very famous connector. We also find in the Raspberry Pi this kind of 40-pin IO, because we want to maybe connect some sensors to this device. So, and also if we look at over here, so it also got the CAN header, a CAN header for CAN projects, if you're interested in that. And what else? Okay, so at the back, what we got the M.2 connector for SSD, right? So because normally the developer kit by Nvidia, like the Jetson Nano, there was no SSD connector. There was no M.2 connector. You want to use a micro SD card. But SD cards, sometimes when you're using micro SD cards, they just die sometimes. I mean, they're not capable to withstand a lot of like read and writes, right? So especially
sustained writes over time, like they tend to break down a lot more quickly than a SSD or even a mechanical hard drive. Yeah,
for sure. So that's why we have this SSD over here, so that we can install the system on the SSD. And apart from that, we got this M.2 connector for Wi-Fi and Bluetooth modules. So right now I have connected a Wi-Fi Bluetooth combo module on this connector to enable all the network connectivities. So that's great. And also it got the RTC battery, so you can just put an RTC battery. The clock, right? So, exactly. So pretty much like when you buy this particular J4012 device, the Recomputer 4012, it also comes with the system already pre-installed on the SSD, so that you don't need to like go around like find the tutorials on how to flash the system to the device, because sometimes people find it a hard time to like flashing the system to the device.
I recall the Nano had some people posting about it was kind of a pain to get the whatever distribution or to update the software even on it. What distribution are you all running on this version?
So actually it's called Jetpack. So Jetpack is the system which is running on the Jetson platform. And right now we are running the Jetpack 5.1. So that's the...
Is it like Debian based or, what?
It's Ubuntu, Linux. Ubuntu
okay,
Linux.
Gotcha.
Yeah. Cool. And it's off of Ubuntu 20.04 right now on this particular Jetpack 5.1 version, right? So so that's what you get with this device. And
and you said 100 tops of compute on there. That's a spicy meatball. It's pretty sweet.
Yeah, for sure. Yeah. So let's move to the next. Let me open the slide again. Okay, so this is what I explained before, the interfaces it comes with. Oh, and I forgot to mention, so you can also have a RTC battery connect to these 2 pins, right? So if you have a connector, like a 2-pin connector with a battery, you can just plug into this connector. So you have 2 options. So this is what I explained before, and this is the back of it, the key E connector and the key M connector with the RTC socket. Okay, so this is the Orin platform. And actually Orin platform was released recently by Nvidia. And they got different Orin modules like Orin Nano, 4GB, 8GB module, the Orin NX, 8GB, 16GB module, right? So this particular Recomputer 4012 that I have in hand today is having this Orin NX 16GB with having 100 tops, right? So Nvidia also has the AGX Orin, which has 32GB. and 200 tops. And the top of the line one is the AGX Orin 64 GB, which offers 275 tops. Right. So yeah, so that is pretty impressive. And yeah, so
yeah,
so that is
it's
about
a lot of hardware in a small package.
yeah. And also I forgot to mention, so when you buy the Recomputer 4012, it comes with like CE, FCC, ROHS, and all these certifications, right? UKCA, so that when industrial customers want to like really integrate this into their solutions, they will have all these certifications ready to go with the product itself. So yeah, so it's kind of like more of like for the industry, the Orin series, because it can really like give the performance to the industrial applications. Yeah. So yeah. And so actually, so if you want to learn more about all the Jetson Orin products and all the other Jetson power devices that we offer, you can visit our website or scan this QR code to learn more about all of them. Right. Yeah.
Yeah, and tell them OpenCV sent you.
Yeah. 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 So let's go into Vision AI now. So what we have today, so basically to test the YOLO, to test the performance of the Orin devices, right? What I have used is the YOLO models. So I wanted to take an object detection model as a reference to do kind of like a benchmark. So that's what I have done. In the
Quick
past
shout
few
out
weeks
to our friends at Ultralytics, who we had on the show a few months ago.
Yeah. Cool. So actually, we also had a show last week with Glenn, Ultralytics, the YOLO V8 live. Yeah, I was there. Last week. Yeah.
Yeah. Shout out to Glenn if he happens to be watching.
Shout out to Glenn. Yeah. So this is actually the YOLO V8 is the latest iteration of YOLO that they put out recently, and it gives like a lot of performance increase compared to other YOLO releases in the past. So this is the particular table that I got from their website, and they offer different models, right? Different like model sizes based on the number of parameters, and like as the number of parameters increase, the model size also increase, right? And when the model size increases, it's very demanding for hardware to perform inference on the model, because the model is very big to handle. And so that's where we want to do the benchmarks and really see like how much of a performance difference that these models are putting out. So what I have done, I have taken 3 devices. So for this benchmark, so I have taken the AGX Orin 32GB H01 kit, which offers 200 tops performance. And I have selected the Recomputer 4012, J4012, with 100 tops performance. And this is actually our one of the earlier products, the Recomputer J2021, which is based on Xavier NX 8GB with 21 tops. So we have 200 tops, 100 tops, 21 tops, 3 devices to test the YOLO V8 performance, right? So how did we test the performance?
One quick question, if we can go to this slide here. What are the price differences between these 2 options, as folks are asking in the chat?
Yeah. Okay. Let me pull up our website. Okay. So if you look at the H01 kit, right, for the 200 tops, H01. Yeah, this one. So for the 200 tops H01, it's gonna cost you around $1,600.
All right.
So for the 200 tops one, but for the 100 tops, J4012 will cost you around $900. Right.
All right.
The 100 tops 4012, $900. And for the J2021, right? J2021 with 21 tops, Xavier NX will cost you around $670. Yeah.
All right. So it's about basically it's about double the price going from the bottom end to the top end of these three devices that we're looking at here. A little bit over double. Yeah. Okay.
Yeah. Right. So yeah. So actually, what I did, I used this tool called TRT-EXE tool to do the benchmarking. So basically, like when you install TensorRT on the device, actually, when you have a Jetson device, you want to install something called Jetpack. So Jetpack includes the Ubuntu operating system, the file system, the bootloader, the kernel, the Linux kernel, and everything is included inside Jetpack. So once you install Jetpack with something, there's something called SDK components. So maybe people familiar with the Jetson will be more will know like what I'm explaining right now. So and there's something called SDK components where it has the other packages such as CUDA, TensorRT, cuDNN, and all these like tools and packages that are needed to run AI, and computer vision stuff. So once you install all this stuff on the device, so I told you the J4012 device that I just mentioned comes with everything that I just mentioned right now, right? Everything is pre-installed on the device. So that's why I told you like it's pretty like much like
basically
ready to go out of the box. Yeah.
Plug and play, as they like to say.
Yeah, for sure. So in that installation of TensorRT, particular TensorRT installation, you have this tool called TRT-EXE tool, and you can use this tool. So you can access this this directory, and you can find this tool, and you can use this tool to benchmark the performance of the models. So for example, in this situation, we have the YOLO V8S model. So first we want to convert into Onyx format because the YOLO by default is trained on PyTorch format. So that is the default model format from YOLO, trained on the Coco data set, which are available on their website, the pre-trained models. So that's what I chose for this benchmark. So
somewhere
I converted the model.
Somewhere out there, Joseph Nelson just cringed when he heard Coco data set.
So yeah, so this model is based on Coco data set, and okay. So as I was explaining, like when it comes to TensorRT, because TensorRT is something that you want to utilize on the Jetson platform, because TensorRT will make sure that all of the hardware resources will be used on the device. So we want to convert the models into the TensorRT format, and TensorRT offers different precisions like FP32, FP16, and int8, like different three kind of precisions. So you can just specify the precision that you want, FP16, and then save engine. So what this will do, this will export the engine file. So it will first benchmark and give out the latency of the model, and then it will export the engine file so that you can use the engine file later for inferencing. So one thing that I want to mention is that, so when you produce an engine file on a particular Jetson device, that engine file can only be used on that device only. So for example, the Jetson Orin NX device, if you generate the engine file, the YOLO V8S.engine file, the TensorRT optimized model file, you can only use it, that particular file generated from the Orin NX, later inferencing on the same device. You cannot use that engine file on a Xavier NX device. You cannot use it on a Nano device. So if you want to use on an Xavier device, you want to again generate the engine files on the device itself, and then use that particular generated engine, and then use it for inferencing on the same device. So this is something to know.
That incompatibility is because of the very specific optimizations it does when you do this. Is that the case?
Yeah, and also it's about the architecture, the CPU GPU architecture,
okay.
And it should match the same architecture to later perform the inference on the same model, right? So this is what I have achieved through all my benchmarking stuff. So this is the three devices that I mentioned: the 200 tops, 100 tops, and 21 tops. We can see that how the benchmarking is panned out. for different YOLO models. So this is the YOLO V5 N model, S model, M model, L model, and X model. The model gets bigger and the performance gets small, as you can see. The smaller the model is, the better the inferencing is. And you can see that when we go like the higher precision, like 32, 16, and int 8, and int 8 can give you the best performance out of all the other precisions of TensorRT. But one thing to note that when you are going because like the thing is like when you go like FP16 and int 8, the memory footprint needed for the model will be less, and the accuracy will get a little low than this FP32 accuracy will be better than int 8. So when you want to use int 8 models, there's another extra step of something called a calibration. So you need to do this kind of a calibration process to make sure that the int 8 model can also can give better accuracy and also the inferencing, because there's going to be a little bit of trade-off by having this much of performance jump from FP32 to int 8, a little bit of trade-off in accuracy, but the trade-off is okay. If you do the calibration, you can get decent accuracy with the high performance, right? So and so this is another way of I have represented it in another way, right? Because this is actually illustrating all the models on one device, but now I have chosen one model and compared the performance on each device. So we have the Xavier NX, Orin NX, and the AGX Orin device, and comparing the performance of these devices. So let's look at the biggest model, the YOLO V8X model. So this is the biggest model from YOLO, and it has the best accuracy, right? And it has the most number of parameters as well. So if you can see here, the Xavier NX has 24 FPS, and the Orin NX 16 GB, right? So this is the device that I have on the show today, the Recomputer J4012, powered by the Orin NX 16 GB module. So when we use this module, this device, the Orin NX 16 GB device, the Recomputer J4012 device, with the biggest YOLO V8X model, we can have a performance of 46 FPS running at the int 8 precision, which is very impressive. So that's why the title of this today's webinar is meeting the server level performance, because most of the data centers also use this kind of big models, right? And if we can achieve like 46 FPS on such a small device with such a big model, I think that is the future. Like we can like see the future panning out for the embedded hardware, and it is really like, you know, meeting that kind of data center and the server level performance at the edge. So that is very interesting to see. And yeah, so of course this is the AGX Orin 32 GB one that we chosen before, the H01 device with 200 tops, having a 75 FPS performance, right? So as we can see here for this particular model, 100 tops, 200 tops doesn't mean it's like actually like double. Like, I mean, it's not like linearly increasing actually the the FPS performance, but yeah. So this is what we can actually understand from the graphs. And yeah, so I think there's one more thing I want to add, and that is okay. So did I have it here? Oh yeah, okay. Sorry, I will tell that later. Yeah. So yeah. So this is about that, and also I have a blog about all the benchmarks that I have done for the YOLO V8 models on all the Jetson devices. And if you visit this link, you can go to that blog, and this is like this blog, and I have yeah, I have talked about all the things everything about all the benchmarks that I have done on these devices, and you can learn more about that. And I think having these benchmarks can really help the community to choose what kind of device and what kind of model that you want to run on the hardware before buying the hardware itself.
Yeah, and as we saw, the price difference is pretty serious, and so it really helps to know what each one is capable of, because when you know what you need, you can not overbuy or underbuy and therefore waste time and money.
Right, that's exactly right. So, and also we have this wiki documentation on how to get started with YOLO V8 on Nvidia Jetson devices using TensorRT and DeepStream SDK. So you can also visit all these tutorials and wiki documents to learn more about all the deployments that you can do at the edge. So yeah, so you can follow along this document. You don't need to buy the Orin hardware actually. You can also run on the old hardware as well, such as the Xavier hardware. So we wanted to make have this kind of wiki so that it can help the community out, the Jetson community out there. Yeah. So yeah.
Yeah, it looks pretty robust documentation wise.
Yeah. And yeah, going into the demo. So let me
Brave Live demo, our favorite thing. Give us the clap reacts in LinkedIn, everybody.
So what I will do now is I have the Recomputer device connected, and let me share my screen again. Share screen. Okay, so I have the terminal right here. Yeah, so this is the device. Oh yeah, and there's this pretty cool tool called Jetson Stats. So once you install it, you can see all the statistics of the device. The CPU
that's a sweet dashboard. I dig it. It reminds me of the HTOP software package that I use.
So actually, yeah, you can find it in this one. So let me go there. Yeah, so it's called Jetson Stats. So I think this is a very helpful tool for the folks out there who have the Jetson device and they want to, view all the statistics. So this is the official repo of that tool, and he has done a great job at making this tool so that
shout out to Robot Rock for the hard work here.
Yeah, shout out to him. Yeah. So yeah, so let's get into it. So YOLO, yeah. So what we do over here, what I will do is I will use my phone and simulate a RTSP video stream because I'm using my webcam for the webinar right now. So
understood.
I will use my phone, and you can, because YOLO V8 supports RTSP video streams directly, grab the stream, right? So I will use an app on the phone to simulate an RTSP stream. And what we will do, YOLO. Okay. So the command for that would be, so once you install YOLO on the device, you just type YOLO detect and then predict. And then you specify the model that you want to run. So model equals YOLO v8s.pd. So we will use that model. And then, so we will specify the stream. So my stream is particularly this stream, RTSP 192.168.188.5540 CH0. Okay, so that's my stream. Okay, so we are using this model, using the source.
Shout out to the real-time streaming protocol, which is one of the oldest still being used, like HTTP, for example. RTSP, first draft submitted by Netscape in 1996, y'all. That is not our trivia question. I just thought it was a cool fact.
Okay, let's run this. Yeah, so try to grab, make sure the stream is alive. Let's see, it will, yeah, okay, the stream is alive. Oh yeah, I forgot to. Yeah. So you need to do the show, right? So when you do this, only it will preview. It will have a preview window. Yeah.
Yeah.
Live preview. Yeah. So otherwise there'll be no preview. So okay. So we have the stream loading.
You can see it's using up all that RAM down there.
Oh yeah. Yeah, you can see that. Okay. So in the other window, we'll just open up this tool, and oh yeah. So we have the stream.
All right. Yeah. Hey, I'm seeing double 4 Lakshanthas. Excellent.
Yeah, I think now it's fine. Yeah. Okay. Yeah. Now it works. Yeah. So because this is actually using the Coco data set.
Mm-hmm.
And yeah, you can.
Very
keyboard, mouse. Yeah. Cup. Okay.
Yeah, it's pretty accurate here.
Yeah. So yeah. So that's the demo. And oh yeah, we can also do this. So we can do detect. We can change this to segment for segmentation. So segment, and there's another model, YOLO V8 seg. So that's for segmentation, right? So because before was object detection, and now we will do segmentation. We'll have a quick look at it. Oh no. Oh, okay. I stopped the stream. Okay.
Speaking of segmentation, quickly, some folks may have seen things are moving so quickly in this industry. Some folks may have seen just this week, Meta released their new model called SAM, which allows you to segment basically anything. I saw Jan LeCun post about this, and it's extremely impressive, and I'm really excited at what capabilities this unlocks for edge stuff like Nvidia Jetson and the other small modules. Yeah, it's really exciting stuff. Wow, look at that. Yeah.
Let me get this mic out of the way.
Pretty damn good segmentation for real time. Like how many frames a second are we doing here?
This is okay. Actually, this is not using the TensRT, but we are getting around 50, more than 50.
Yeah, I see it's about 23 milliseconds per.
Yeah. So
very cool.
Yeah. So that's about segmentation. Yeah. Talking about the SAM, that is something that I will quickly go through the YOLO V5 models, because YOLO V5 is also very famous, like for many years. So that was actually one of the most famous models for object detection. And like these are some of the the models that you can find for YOLO V5. And I also did the YOLO V5 benchmarks on the Jetson, right? So and then so actually for YOLO V5 we have this wiki. If you want to get started with YOLO V5, you can go to this wiki and then learn about how to deploy YOLO V5 to the Jetson device, right? So we have this wiki as well. You can go through all that cool stuff. And what is interesting is that if you have the Orin AGX Orin, this developer kit, you can emulate all the Orin devices that I mentioned before. So the Orin Nano 8, 4.8, so all these devices before. So there. So Orin Nano 4GB, 8GB, NX 816, AGX 3264. All these 6 devices can be emulated on the developer kit. So AGX Orin developer kit. If you have this developer kit, you can emulate all of them. So it is very interesting, because if using one device, you can make sure that you can once you emulate a particular device, you can see what kind of performance that you can get from that device. And if you have a model, and you can really see like if the model is if the device is too much for the model or too little for the model. So you can actually like really like have a very optimized device for the model that you want to use on the Jetson. So once you have this developer kit, and emulate all the Orin devices. Yeah. So this is also something that I want to mention here. Yeah, about the emulation.
Pretty sweet.
And yeah, and about the YOLO V5 and the V8 benchmarks that I did. So after doing all these benchmarks, I found actually they are like they also say that even though YOLO V8 is new, it has better accuracy than YOLO V5, but when it comes to inferencing speed, it will be a little less than YOLO V5. So they kind of like compromised on the speed to get much more accuracy than YOLO V5 with YOLO V8. So as you can see from all these benchmarks, the YOLO V5 model, the YOLO V5, the blue V5 model is performing better than YOLO V8, a little better, maybe like 4 or 5 FPS more, or like 10 at the most compared to YOLO V8. But if you compare, look at this graph, which is posted on the official Ultralytics GitHub, we can see that so this is the number of parameters and the accuracy. So the accuracy is higher for the YOLO V8 models. You can see the X model has higher the accuracy than the YOLO V5 model. The V5 model is the pink one. Yeah, so it's higher than high accuracy, right? But so that's a little bit about the difference and the benchmarks also that I did for both the models, right? And yeah, so okay, so now we can see that we can have a lot of FPS, right? So what does it really mean to have a lot of inference? So for example, you have a Orin device and you get like, for example, this AGX Orin device, right? The one I showed before, the AGX Orin 32GB device, the running YOLO V5, YOLO V8 in model with int8 precision. You can have 385 frames per second, but it is not really practical to have 385 per second frames per second for one stream. It's just like really too much, right? So how can we really benefit from this much of FPS? So that's when we want to talk about the multi-stream applications. So if you want to deploy many cameras at the same time connected to one device, so all the FPS will be divided into the number of streams. So to verify this, what I have done, I have used the DeepStream platform from Nvidia, DeepStream, and it supports to run multiple streams at the same time, using the same model. So here you can see. Hello?
I can hear you.
Okay, so here you can see that we are using the YOLO V8S model with the AGX Orin 32GB and the int8 precision. So as we saw before, the 300, yeah. So this is the 385 frames per second, right? The YOLO V8N model. So if you divide this by the number of streams, so here I have chosen nine streams. So we divide 385 by 9, which we get 43 FPS. So which is pretty close to the one that it shows. It says like 38, like around 39 frames per second per stream. So, and also like here, the YOLO V8S model running on the same device. So the int8 precision with YOLO V8N model, we can have a 303 FPS. But if you run DeepStream with multiple streams benchmarking, and here we have 9 streams again, and if you divide the 303 by 9, we get 34 FPS. And actually, this actually verifies that. So we can see around 33 to 34 FPS per stream, right? So what we can do is we can have this kind of benchmark table, and then we can decide, okay, how many streams that we want. Okay, 5 streams. So we get the 385 frames per second divided by 5, and then we can really see like, okay, then 385 by 5, we can get that number for one stream. So yeah, this is how it can help uh, to verify for the running the multi-stream applications.
Yeah, that's really impressive. So you could have nine camera feeds going in there and getting 30 plus frames per second for each one. That's
Yeah.
quite
Yeah.
impressive.
Yeah. And yeah, so
I
these
feel
are
like
some of the
most applications will not nearly need 9 cameras.
yeah, for sure. Yeah, that's true. But sometimes like you don't want to connect like 9 cameras to the same device. Maybe the device is located in another place and you are streaming the video feed to this device because this is acting as a server, right? So it's just as if you're sending the stream to a cloud service. You're sending to the stream to a device which is located in another location. But it's your own device. So in this situation, you can have multiple streams from different locations coming into this device and doing all the inferencing at the same time for all the streams. Yeah. So that's where it really shines. The Orin platform running at the edge. So yeah, so these are some of the demos that I tried with YOLO. So I just did like a car detection. This is an intelligent transportation application, a people detection application. Yeah, so this is kind of like an agriculture application. Like you can count the apples and can see. So this is sheep counting. So yeah, so for all these detections, I use the Coco dataset trend models on YOLO. Yeah, they are doing pretty well on the Orin device.
Yeah, cool visualization here.
Yeah, thanks. So, oh yeah, and then yeah, so that's all about the Orin devices, the benchmarks, and all the cool stuff. So actually, I highly recommend to go through the wikis that I mentioned before. So like the folks out there can really like learn a lot about the deployments happening at the Jetson and even like gain more knowledge about the edge deployment in general with the Jetson. Yeah. So and also so actually yeah, so we are almost like at the end of the show. So before we finish off, like I want to mention about a speech AI application running on the Nano, because the reason I want to mention about this is because earlier when we have the Jetson Nano, Jetson Nano was not able to do any kind of conversational like speech AI applications on the device. At the edge, speech AI was not even possible. So with the Orin, so Orin actually makes the way to deploy speech AI applications at the edge using something called Nvidia Riva. So Nvidia Riva is like a speech AI, like conversation AI platform where you can deploy speech AI applications on the Jetson device. So especially like they focus they are trying to focus more on the edge devices right now because of the power that the Orin can give. So if we look at the benchmarks for that as well, so for the speech AI, I just want to like highlight a little bit about this because I think like conversational AI stuff is also like pretty hot these days, and it's really nice to see it on the edge now. So
yeah, we're just getting more and more popular out there to see the speech recognition. It's one of those that has lagged behind, I would say,
actually,
a little bit.
The Nvidia Riva platform. So as I was saying about the Riva platform, the Nvidia Riva platform. So with the Orin, so we can see that, okay, so the Riva platform has the ASR, which is automatic speech recognition. And there's the NLP, which is the natural language processing. And there's this TTS, which is text to speech. And the NMT, which is natural neural machine translation, right? So the Riva has 4 services. And like, these are the benchmarks that I've actually like gotten from the NVIDIA official documentation, the docs, and this is the latency that it offers. Like like you can see like 14, 16. This is ASR like in English, 14. So based on the different languages, the latency will change. It may be because of the model that is used, the model size, right? So depending on the language. So
those are still really good numbers.
Yeah. So this is actually running on the 64 GB dev kit, the one that I showed before, the biggest, the highest end platform of the Orin series with 275 tops, right? So that is the device that these benchmarks has been done. So so that is the Riva platform, and actually I want to quickly show how the Riva works on the Jetson. So I have a speaker and a mic connected over here. I want to quickly show another demo. That will be our last demo for this show. Yeah. So let me okay, go back this one. Okay, share this. Go back to my terminal. Okay. So now the Riva is running on the J4012 device. Okay. So actually it's running as a server. So we need to start it. Once we start it, it will bring up some Docker containers. It will run in Docker. Yeah, so okay, it's starting up the server. So actually, when we are running this Riva server, you don't need to connect the mic and the speaker to that particular device, but you can use another device and you can point to the IP address and the port over here where the server is running on the Jetson. So you can place the Jetson here, and then you can use another device to access this server. Yeah. So okay, so it's trying to load up the models. It'll take a couple of seconds. Yeah, because like this is something that I have been working on recently, like in the past few weeks. Because the reason I want to show you is because I have this idea of creating a local chatbot with Nvidia Riva and OpenAI. So this is actually this is the Riva ASR service that I mentioned before, and then this is the Riva TTS service. So ASR is the automatic speech recognition, and this is text to speech. So what we will do is we will connect a mic to the Nvidia Jetson, and we will ask a question. We will like say something to the mic, ask a question, and that speech will be converted to text, and we can then send that text. Like use the OpenAI API, use the GPT 3 or 4 model, GPT-4 model, like, and then we can send the request, and then the API will give back the response according to the question that we ask, and then that text can be converted back into a speech, text to speech, and then the speaker will speak out the answer. So, so this is something that I'm working on at the moment, and I have successfully able to do this part, except the OpenAI API part, the local part, the ASR service and the TT. And yeah, so this part is the one that I'm trying to accomplish, and maybe in the coming weeks, like I will create this and maybe write some document, do some wiki, yeah, and share to the community.
As Jagadish in the chat says, basically you're building your own Jarvis from Iron Man.
Oh yeah. Yeah, pretty much. So yeah. Okay, so this one, okay, yeah, now it's running, right? So what we will do, we will try to okay, where's this? Sorry. Yeah. So first we will do some ASR, right? Automatic speech recognition. So yeah, so for that one, so Riva also actually comes with some examples to do that. So Python 3 is we want to list the devices first. Oh yeah, there's one more thing, like when you are running the Jetson, you want to make sure that there's this thing called Jetson clocks. So you want to enable this. So this will make sure that all the CPU and the GPU clocks will be maxed out, right? So this is something important that you want to note that when you're running some application like AI application on the Jetson, because this is not turned on by default. Yeah. So just turn it on, Jetson clocks, and then so actually when you are running the Riva, it takes up about 13, like 12, 13 GB. Like you will see here, the RAM will be totally like kind of maxed out.
As it starts,
you
you
see
see
like
it
10,
allocating there, yeah.
12, yeah. Because the previous Jetson hardware did not have this much of RAM. So like this is 16, right? And the
weren't they like 4 and 8 gigabytes before or something like this?
Yeah. So this is 16, and the AGX Xavier is 32, the top of the line. So okay, so this is okay. And then let's do examples. Yeah, Python 3. Because I got some what do you call it? Tongue twister for it for Texas page. So
all right.
Yeah. Let's try this one last time, and then if it also does not work, then we can proceed there. So, oh yeah, so you said there'll be an edited version, right?
Yes, indeed. We'll put it up on Tuesday, and so we can clean up some of these rough edges on this episode.
Okay, that sounds good. Oh yeah, and maybe all the breaks of me like breaking out. Yeah,
precisely. There's a reason we do a little bit of post-production on this show.
Okay. So what's that? Okay, let's try now. Okay, it's up. So yeah, okay. So we do the input device. It's 24. Great. Hello.
Nice.
How is the weather outside? Yeah, it's pretty fast, you know.
She sells seashells by the seashore. Not bad.
Yeah. Not bad at all.
Rubber baby buggy bumpers. Not bad.
So, and everything happened locally, so yeah.
That's cool. Yeah, it's interesting to see it kind of correcting itself. Yeah, this is neat.
Oh, sorry, it's input device.
Yeah, you had a typo there. That's what it was. It was output.
Is it? Oh no, I didn't see that. Oh no,
I didn't catch it either. Thanks to our trivia shark Partha for noticing in the chat, and also Thomas.
Okay, so now let's do this tongue twister for it. So I have the Peter Piper picked up. I have that one. Okay, so let's try that. So I have the
Peter
mic
Piper
over here.
picked a peck of pickled peppers.
Yeah, let's try that.
Oh, Peter Piper picked a peck of pickled peppers. A peck of pickled peppers Peter Piper picked. If Peter Piper picked a peck of pickled peppers, Where is the peck of pickled peppers Peter Piper picked?
Yeah.
Solid.
So-
Solid.
Yeah, pretty much. Yeah.
Sweet.
Yeah.
Cool demo. We got
So-
there. We got there.
We got there finally. Yeah. So this is what I want to build out of it. So we have the speech recognition and we have the text to speech. So I just need to add the OpenAI part
Yeah.
to get the responses from the answers. Yeah. And finally, so I think we are almost done. So I think I have the question. So shall we show the question?
Yeah.
trivia question?
So folks, thanks for sticking around with us. Now is your chance to win one lucky winner will get a $100 coupon for Jetson products on the Seed Bazaar store. Answer in the Zoom chat window. Lakshantha is going to be our trivia asker today. The first person to answer it correctly in the Zoom chat will win that coupon. Go ahead. If you've won in the last couple of months, don't answer. Give someone else a chance to win.
Okay, so today's trivia question is going to be, how much FPS can you obtain if you run the YOLO V8X model with int8 precision on a Recomputer J4012 device, the device that I just showcased on the show?
It's real specific.
Yeah.
All right, watch the chat here. Make sure you can call out who wins.
Okay.
I don't know the answer to this one.
Okay, I think we have a winner.
Who's our
We got a
winner?
46 is the answer.
46. It looks like
Yeah.
the answer was Nagma Anwar.
Anwar. Yeah.
Congratulations.
Yep.
Please send one email to phil@opencv.org and we will make sure that you get that coupon from our friends at Seed Studio. Congrats.
Congrats, Nagmar.
Yeah. Gosh, we have a bunch of questions. I mean, we're coming up on 30 minutes past the hour. What else you got for us before we say goodbye today, Lakshantha?
Yeah. So are we going to answer any questions? So
Yeah, we got time. I've got time if you've got time.
okay, yeah, I got time.
Okay, let's go ahead and unshare your screen.
Okay.
I'll pull some of these questions real quick. We've got a slate of them.
Okay. So let me check this. It's the Zoom questions from Zoom, right?
Yeah, I'll ask these here. Go ahead and unshare your screen so people can see our faces.
Okay.
So Jagdish would like to know, are those the 40-pin GPIO connector, is that compatible with some of the Raspberry Pi or BeagleBone hats out there? Or is it just a slightly different layout?
Actually, yeah, we have not tested. So it depends on whether like you have done it test beforehand. So for now, we have not tested any hats on the 40 pin. So we cannot really like say like it's going to work or not. So we want to test it. But the layout is a little similar to the Raspberry Pi 40 pin. But if you really want to know about the layout, then what you can do is you can go to the Orin NX documentation, and then you can get okay. So for example, you can go to our website, the J4012 Recomputer. Just search for that, and down below you will find the data sheet for the product, and in that data sheet you'll find all the pin definitions, and based on the definitions you can decide like what kind of hat that will work. But for now I cannot really like give an answer for that because we have not tested the hats with the board.
So we saw some of the business use cases on your slide there. That was cool with, for just running Cocoa to livestock tracking, people tracking, things like that. That was one of the questions here. For the devices that are, Johnny would like to know, for the devices that are available now, what would be your recommendation for use cases like drones, autonomous vehicles that specifically maybe airborne ones?
Sorry, could you repeat that, please?
So of the currently available NVIDIA devices, what would you recommend for someone doing a drone project, a flying drone project?
Oh yeah. So for a drone project, then you would want to go with something like we have a small. Let me bring that the product up. So for drone projects, specifically with small scale projects, this is actually a very small carrier board that fits the Jetson Nano, Xavier NX, and TX2 NX. The three modules are supported by this A203 V2 board. And compared to the other Jetson carrier boards, this is very small. This is like half the size of the compared to the other ones. Like it's very small form factor. So this kind of small factor is suitable for drone. But of course, you can also use another platform like this, the normal platform, the Xavier Nano or the Orin, the dev kits as well, or the recomputer platforms as well. But it depends on what kind of form, the size you're looking for. If you're really looking for the very small size, then this kind of solution is what we have. This kind of small form factor solution, and we are also trying to bring the small form factor solutions for the Orin platform as well, because this is only for Xavier, TX2, and the Nano. So we will bring this kind of small factor form factor for Orin as well very soon. Yeah.
Cool. That makes a lot of sense. R would like to know, are these Jetson devices robust enough to contend with external weather factors like high humidity or extreme temperatures? Like what sort of things have you seen with people using these not in a sort of laboratory safe environment?
Yeah, that's a good question. So most of the devices that are out there, the Jetson devices, they are mainly, if you want to they are not mainly designed to withstand these harsh conditions. But for that kind of situation, you want to have something like an industrial board, right? Which can withstand the maybe harsh environmental conditions, as you mentioned. So we also have this kind of industrial. We are trying to bring, as I mentioned before, in 2023. That is like our plan to bring out more industrial products as well, which can really fit this kind of demanding scenarios. So because in this kind of situation, we really want to make sure the exterior is the one which will really play the part, because when it comes to the Jetson, the carrier board and the module will sit inside, and what we want to focus is the exterior to withstand all this stuff, the demanding environmental scenarios. So that's what we will be doing in 2023 to address this this applications.
Yeah, thanks. That's makes sense to me. Appreciate the answer there. Yeah, I think we're about time to call it a day here. Thanks so much, Lakshantha, for the presentation here. Thanks for joining us again for your second episode.
Yeah, sorry to interrupt there. I think I forgot to share our catalog, the one that I mentioned in the very beginning, right? So folks can go to this, visit this. Okay, let me swap this.
Yeah, a lot of questions of, where can I buy these? So make with the link.
Yeah. So, okay. So this is am I sharing screen? Okay. So this is the product catalog that we released last month for all the products that are releasing in 2023. So you can visit this URL 2023.seed.cc. You can visit this URL, and then you can find all the information on how to get that catalog in hand. Yeah. So again, visit this URL.
2023.seed.cc.
Yeah. And also, if you want to learn more about all the other products, as I mentioned before, you can visit, you can visit this seedstudio.com, right? sagestudio.com, and that is where we have kind of like our marketplace for all the cool stuff. Yeah. So this is the official marketplace. Yeah.
Excelente. Thanks so much for the presentation here. Thanks for joining us again for your second episode. We had some hiccups, but we'll fix it in post. And by that, I mean, I'll fix it in post. Thanks so much to everybody for joining us this week and sticking around through some of the technical issues. And we really appreciate you every single week joining us here on OpenCV Weekly Webinar. We will be back next week, same bat time, same bat channel, 9 a.m. Pacific on Thursday morning with Joseph Nelson of RoboFlow talking about their awesome launch week. We hope to see you there. Take care of yourselves out there and take care of somebody else if you can. Adios. Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by OpenCV Courses. Learn computer vision and AI from the best at opencv.org/courses. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.